All right, are you sick of L equals 2 to the n? Are you tired of drawing truth tables that have 8 lines, 16 lines, 32, 64, 128? Actually, I didn't give you any problems that required, I don't think I gave you any that even required 32 lines. But at any rate, if you're not digging the line drawing, this is a good week for you because this week we're going to learn how to create a different kind of truth table that will often require you to create just one line to evaluate a set of propositions or a given argument. And in fact, with the problems we're going to be working on this week, I don't think you're going to be creating many truth tables that are more than 2 or 3. Maybe there's one you have to create 4 lines for, I can't remember, but most of them you're actually going to be able to resolve with just one line. So good news for the people who are not fans of line drawing. Now, there's a couple of things I want you to take note of, and I mean that literally, like write these down because they're super important things that you don't want to forget. And the first is a distinction in terminology. So last week, the truth tables that we learned to create were called ordinary truth tables, or are called ordinary truth tables. These are the truth tables that we very mechanically create using that L equals 2 to the n. The truth tables we're going to learn how to create this week are called indirect truth tables. And these are the truth tables that involve a little bit of a different skill set. You're not going to be using any formula to be drawing lines. And the reason that it's important to make sure you're clear on this distinction is that your final argument construction assignment that you have coming up in a few weeks is going to ask you in some problems to create an ordinary truth table and in other problems to create an indirect truth table, okay? And every single semester, people don't notice that distinction between those two terms, and they end up creating the wrong kind of truth table, and then they forfeit points. So make sure you're always mindful of the difference between ordinary truth tables and the features of indirect truth tables that you're going to learn about this week. Okay, second important point that you want to write down is this. With ordinary truth tables, when you're using L equals 2 to the n, those truth tables are going to look exactly the same no matter who creates them. So if you give 10 people a given argument and you say, create me a truth table for this argument, every single line is going to look identical on their truth table. So it doesn't matter who creates the truth tables with ordinary truth tables. If you're using L equals 2 to the n, those truth tables are all going to look the same. But that's not the case with indirect truth tables. Indirect truth tables are going to rely on a much less mechanical, much more sort of critical thinking skill to create them. And what they end up looking like is kind of going to depend on the approach that the person creating the truth table has taken. What that means for you is this, is that when you create your indirect truth table, see if I can show you an example here. When you create your indirect truth tables, you're oftentimes going to run into a problem, and that'll make more sense as you get into this week, but you're going to run into a logical problem. And when you run into that logical problem, it's either going to prove the argument valid or it's going to prove the statements to be inconsistent. Now, where that problem occurs on your line in the truth table is going to vary depending on the person and how they went about creating that line, okay? So what I need you to do, and this is the note you want to take, it'll make way more sense when you start getting into this week's work, is you want to make sure you make really clear to me where you run into a logical problem when you're creating your indirect truth table. So you can see here in this video on your screen, you can see I've circled right here. And I've circled it because you can see we have a horseshoe. And you can see that the left side of the horseshoe is marked true, the right side of the horseshoe is marked false, but the horseshoe's true. And we know that's not the case. In fact, that's the only set of true-false combinations for a horseshoe that makes a horseshoe false, okay? So there's a logical hiccup here. And whenever you run into these problems when you're doing your work on your thought primers this week, you want to either circle where you run into the problem, because that's where you're going to stop your work, or you can, some people will do a highlighter through it, or if you're the super fancy alpha Excel type and you're creating your truth tables in Excel, they'll color code the area of the truth table where they've run into the problem. I don't care how you do it. You just want to make it easy for me to see, because I'm going to be going back and recreating all of your work and how you arrived at the conclusion that you did. So I've got to be able to see where you ran afoul when you were doing your truth table. All right. That is it. It's going to be a fun week. I think indirect truth tables are one of the more fun things that we do in this course because they're very much like solving puzzles. And so if you approach them that way, it'll be kind of fun. All right. Have a great week and make sure you let me know if there's anything I can help you with.